Be looking at measures of variation now instead of measures of center. Variation is just looking at the data. How spread out is it? So visually, we can look at it when we look for what we call gaps or spaces, or when the data is clustered or grouped together. And so we want to look at this spread. Sometimes we look for these little things called outliers, and that would be some value or a few values that lie away from the rest. So what we're going to do is look at these numerically. We're going to find a number that actually quantifies the variation. So the simplest one is range, and that is just when you take the highest value minus the lowest value. This is good when we talk about weather. The, the temperature range today from 80s to 60s. We don't use that one very much. The interquartile range, we've already defined that. This is basically the size of the box. In other words, it's Q3 minus Q1. And so you could look at that box plot we made earlier. One quartile range was very narrow, and the other was much longer. And so that would tell us a little bit about our variation. But we're going to focus on mostly the mean average deviation and the standard deviation. The mean average deviation is simply what we did on the posters. We looked at the average distance from the mean. And we looked at absolute value. That's what those symbols mean, is absolute value. So if you recall, we had an average family size of 5. And what we looked at is if I had a family here, that was a positive 1. If I had a family, down here, that distance from the center would have been 2. And that's how we kind of did that balance point. And that's called the mean average deviation. You just add up the distances and average them. What we're going to mostly focus on is the standard deviation. And the standard deviation is used to determine what we call the distance or the spread, and it's going to quantify it. Quantify the spread. So let's just think about some values. If I tell you the spread has a measure of 10, that was my standard deviation, versus a measure of 2, the 10 would be much more spread out than the 2. The 2 values would be close to the mean, and the 10 would be far from the mean, meaning that we would have some values that were way out there that would make that number much larger. So if I had all my families at size 5, I would have a standard deviation of 0. There is no spread. If I had a poster up there and one of my family sizes was way out at 12, the standard deviation would be pretty large because that's far from 12. So what we're going to do is learn how to calculate this thing. And there are some mathematical symbols that go with it. This symbol, it's a circle with a line, is called sigma. It is the standard deviation of what we call the population. The population is if I have all of the items. Not very likely that that's ever going to occur. So we're going to do, this is the letter S, and it is the standard deviation of the sample. We're going to do 1 standard or 2 standard deviations by hand, and then you'll be shown in the class how to calculate these using a calculator. So let's suppose I have a data set, and we're going to make it awfully small here today. The data set that we're going to use are the numbers 0, 5, and 7. So if I was supposed to find the mean, or the arithmetic average of this, I'd add them all up, and I would divide how many there are, and you do count the 0. That is one value in my data set. My mean is 4. You're going to learn another symbol today. X bar is equal to 4. So X is the mean of the sample. So we call it X bar. So the mean of the sample is X bar. So what we're going to do with this is we're going to find out how far each of these data values are from X bar. So we're going to have a little table here, and we're going to go my value X, or my observation, minus X bar. So since I only have 3, it's going to be 0 minus 4, 5 minus 4, and 7 minus 4. So the first one has a distance of -4. The next one has a distance of 1, and the third one has a distance of 3. So I have those three values. Now what we don't like about them is it could be negative. So we always like to have distance be positive. So the next part of the table says, let's take this quantity and we're going to square it. Because if I square something, I can always undo it by taking the square root. So when I square, -4, 6 makes +16. 1 squared is 1, 3 squared is 9. Then what I'm going to do, since this is the average distance, I'm going to find the sum, which is 26. Once I've added them up, what I need to do, if it's the average, we're going to take those 26 and we're going to divide it by not 3. There are 3 values we use, so if I was finding the arithmetic average, I would divide it by 3. But in this case, we're going to divide it by 2 because of this idea of degrees of freedom. And what degrees of freedom say is 2 of these were free to be whatever they wanted to, but the last one was stuck. So we'll talk a little bit more about that in class. When I get the result out of this, it's 13. But remember, I squared all this, so my value that quantifies my spread is going to be the square root of 13. S equals the square root of 13. As soon as I say S, we know it's the standard deviation of the sample. So the standard deviation has a formula. So the sample standard deviation is equal to, and what did we just do here? Well, we're going to put some mathematical symbols in here. We took the sum, that's what that means. We added up the x, my observation, minus x bar, and we took that value there and we squared it. So recall, we squared the difference so that it was positive, then we added them all up, and then we divided by n minus 1. N is the number in your sample, and then at the end we had to take the square root to undo the square that we had. So it seems like a kind of a complex formula, and the calculator does a wonderful job at doing that, and you'll have some of these in iMathis. So we'll learn how to use that standard deviation and the importance of it in the next lecture.